Assalamu alaikum. Start your presentation by introducing yourself. Myself is Abbas. I am from BS5 Technology Department. Share what you are presenting. My presentation topic is stem correction for artificial manufacturing. First of all, we show contents. First, introduction, second, apparatus and method, third, formula, fourth, stem correction table, and five, question. First, introduction. What is stem correction? A correction applied to the reading of a precise thermometer to allow for a difference in temperature between the liquid and the stem that in the bulb. In many industrial operations where thermometers are used, the form of the apparatus may prevent the placing of the thermometer so that its entire mercury column is immersed to the temperature of the bulb. Under such conditions, the temperature of the stem in general differs from that of the bulb. Thermometers are commonly used to read correctly only when the entire mercury column is at the temperature of the bulb. And if used otherwise, they will be not indicate the true temperature of the bulb unless corrections are applied to their reading. A particular example, this is an example of temperature. A particular example is just a use of thermometer in distillation frogs where the correction may amount to 50 degrees or 20 degrees under actual distillation condition. Second, operators and method. First, frogs and thermometer used. Four types of distillation frogs. We use the retort frog. This is the first frog by the American Railway Engineering and Maintenance of Association. Second, the humper frogs are used by the Forest Service. The long side neck frogs recommended by the Community of Representative Treatment of Poles and Cross Arms of the National Electrical Light Association and the ordinary 200cc side neck frogs. Their dimensions as follows. Diameter of ball 8 centimeter, diameter of neck 2 centimeter, height of neck 50 centimeter, distance from water of outlet tube the top 8 centimeter. All the tests were made according to the specification for applying to the particular form of apparatus. Used specs where special experiments were made to determine the effect of the variation from the specified procedure. The graduated stem continuous scale type of micro thermometer 40 centimeter long graduate into interval from 0 degree to 400 degree are used. The length of the interval was 0.8 millimeter. The distance from middle of bulb of 0 degree mark was 2.5 centimeter. The thermometer was filled under pressure to prevent distillation of the mercury and was well unused to prevent arise the reading will continue hitting. There are different types of distillation frogs used and this position of thermometer. First of all, we know frogs. So there is a thermometer down and the humper frogs, thermometer up, and the lung frogs, and fourth is the side neck frogs. Types of different frogs used and positions. Second, methods used to determine emergent stem correction. First, for measuring the temperature of the stem, this was made of a number of special thread thermometer made up and calibrated for this purpose. An auxiliary thermometer for the pod of the stem not covered by the thread thermometer. With this thermometer, the mean temperature of the emergent mercury column over this entire length could be very closely observed. The use of this thread thermometer is discussed in detail in a previous publication. This is the five for most of the apparatus and the crystal eye were introduced by the Bureau of SI cuts by the Product Manufacturing Corporation. What is the result? Emergent stem correction table. Average emergent stem correction applicable for the particular type of thermometer are used in the different distillation frogs. Were determined for reading taken on the thermometer at every 20 degree from 200 degree up to 350 degree. The emergent separation are given on the table. Distillation frog choose the thermometer. Here I am performing a distillation where is the why is the thermometer placed at the top of the column is set in the solution. First of all, so that the pressure of the vapor is measured. Top of the column measure vapor temperature, water out, water in temperature, water in and the thermometer after in the solution measure solution temperature constant, water in, water out, and the thermometer is down. Different flocks, different shapes of flocks we use in determine the emergent step fraction, conical flocks, volumetric flocks, round bottom flocks, Lorentz flocks. Temp fraction formula. There is an important formula. Fraction is equal to k n capital G minus T. This is the value 0.0016 multiplied 16.50 multiplied 90.50 minus 25 is equal to the actual value 0.627. According to the value to observe reading, our thermometer is 90.50 degrees plus 0.627 is equal to 90.777 degrees Celsius. This is the actual temperature of the liquid being measured. Notice how much greater the fraction is. 0.001 multiplied 60.53 multiplied 90.15 minus 25 is equal to 9.318. There is a value was observed reading on the thermometer is 90.50 degrees. This is the add of the value in this thermometer is plus 3.918 degrees equal to 94.068 degrees Celsius, which is the actual temperature of being measured. There is a final temperature. Temp fraction table. Emergence step fraction table. Average emergence step fraction applicable for the particular type of the thermometer is used in a different distribution form, but determined for reading taken on the thermometer at 20 degree from 200 degree up to 350. The emergence step fraction found are the given table. This is the table. There is a different four types of flocks. There is a reading and in reading without flocks, sample flocks, some flocks, or flocks. The correction are given in the tenth of a degree, but an sections for the curves plotted for the different runs show that for the same reading, the emergence step fraction may differ by over a degree from one term to another. For this reason, this fraction may be reliable for better than a degree. Question: how to find out emergence step fraction? This is the final equation. The equation in degrees given by the k is equal to n capital A. N is the number. N is the number of the degree of the scale of S and at level included in one scale union of the value stamp A. The problem is now to determine the value of A of observation on A and for the purpose really in addition to reading when in a position show on the reading which total immersion and the temperature field. Thank you. Have a nice day.